So today we will cover few things. First, we will, even if it's not part of Unit 1, 2, it's part of 3, 4, but we will learn it this year. The Euler's number E. E. What is, it's 2.7, approximately it's 2.71, and it is like pi, it's irrational number which going forever. It cannot be, what does it mean irrational number?
It never ends.
Cannot be represented as a fraction. Now where it came from and why it called Euler's? The actual number was found or introduced in mathematics by Italian mathematician, physicist Bernoulli. And the interesting thing, this number came from the finance. From the finance. When he was investigating how to calculate compound interest. What is compound interest? When interest calculated on interest. There is a simple interest when interest is calculated only on the principal, but compound when interest is calculated, and interest calculated on interest. And Jacob Bernoulli, his name was Jacob. Yes. He first introduced that number, that when we have one sequence 1 plus 1 on n in the power of n, calculating the compound interest, he came across this. And when he was increasing, calculating n, greater and greater number, more proper mathematically we will write it using some notation which you will learn in term 3, only limit of 1 plus 1 on n in the power of n when n approaching infinity, that is number E. So this sequence, this came from the calculating of the compound interest. And that, now, why now, if this number was discovered by Bernoulli, why it called Euler's number? Because Euler did a lot of investigation with this number, and he found that this number can be represented in a different way. You will, usually in the textbook, you have this way of represented, but Euler found that E also equal if we do sum of 1 on n factorials from n equals 0 to infinity. Now this means sums of what is, do you remember what factorial is?
Yes.
What's going on there?
I think, Mr. D, I turned around for 1 second and I looked back and I clicked that on here.
What is factorial? Who forgot? Let's say 3 factorial is 1 times 2 times 3. That is factorial. And so if I will have to remove someone, and if we calculate 1 on 1 plus 1 divided 1 times 2 plus 1 times 2 times 3, and we'll continue, we'll get to the same number. We'll get to the same number. That's Euler found, and that's why it's called Euler's number. Now,
Oh, that makes sense.
Euler, now, why this number is important? Because these kind of sequences, this kind of relation comes up in many practical applications. And you will be surprised, one of the areas where it's of science, where it comes very often is biology. In biology, this, of course not in that biology that you learn at school, but in population models, the number E comes up in many actual real life applications. So that's why it is important. It is, after pi, it's probably the most often used number. So that's what is E. What we will be using it for, we will be using it for sketching the graph E in the power of x. And this graph, because E is greater than 1, so the graph will be, as usual, exponential graph with the y-intercept at 1 and going up. And with the y-intercept, need to change role. So, with the y-intercept 1 and the asymptote y equals 0. Also, and with the logs, log with the base E, it's so important, so like often comes in different applications that it has name natural logarithm. So it naturally comes in many real life situations. And even if the international notation is ln, that means with the base E, and on your calculators it says ln, in your textbook, for some reason it's used log with the base E. So log with the base E.
Is that wrong or is it just worse?
I don't know. In here, like in Australia, there are few notations. They invented few notations different to international. For example, inverse function, so inverse circular function, which you have not learned. It's like, you use them to calculate angles, so sine -1x. It's not international notation. International notation will be arc sine.
Oh, what? Arc sine.
That is international notation.
So why don't we do it in international?
I don't know again, this is the international notation, that's what we're doing here. But when you, yes, even on the final exam, if you write, you can write ln x, it will be completely accepted.
Will we need this for this term?
E, number E, of course, yes. Because we're doing logs and exponentials. We're not.
It doesn't matter. It just matters if it's like the same as like number 2.
It's just a number. E is just a number. You will see in term.
Why do you ask you?
In term 3, when you learn calculus, you'll find interesting. No, actually, it's not this year. You'll learn the differentiation of the exponential function next year. But just jump a little bit ahead, the interesting fact that derivative of E in the power of x equal function itself. That's pretty much unique situation. We have not learned what the derivative is, just how unique, interesting this is. And derivative of ln x, derivative equal just 1 on x. So those are pretty interesting facts about number. Another interesting fact with the number E. But for now, you just need to know that such number exists, and you need to, if you're solving it, just solving it as with the number. And let's say, example, let's do some example. Page 11. Page 11 of your booklet. And we have example 3. Sketch the graph of f of x equal e in negative x plus 1. First,
Oh, that's log graph.
not log, e in negative x.
Okay.
What transformation is this?
Reflection.
Reflection in y-axis. So that will make graph like this. Now what plus 1 will do?
Move it up.
Move it up. So asymptote will be y equals 1.
Oh.
Y equals 1. What will be the y-intercept?
2.
2.
There you go.
So that will be the graph.
Yeah.
Oh, that's not. That's not.
This is 0, 2. So it's not hard at all.
Do we have to have any other points?
No, there are none.
No.
Okay.
That's just about number e. So it's just a number.
Wait, what if it wasn't reflected in y-axis? If it was e to the x plus 1?
If it will be e in the power x plus 1, then it will be asymptote y equals 1, and that will be the graph.
Yeah,
We'll
okay.
be that way.
It's like mirror. Like, no. Yeah.
Yes.
That will be e in the power of x plus 1.
Yeah.
Yasha. It is mirrored.
Now,
House is yes, very.
what is
Oh.
the relation between the exponential function and logarithmic function? What is the relation between exponential function and logarithmic function? For example, 2 in the power of x, 2 in the power of x, f of x equal 2 in the power of x, and we have g of x equal log x with the base 2. What the relation between those two functions will be?
The base is the base.
Oh, yes, it's inverse.
They are inverse, yes, they are inverse. So, let's say how we see that it's inverse. Y, so y equal 2 in the power of x. How we find an inverse function? What we do? We swap x and y, so we have x equal 2 in the power of y. Now, let's take log of both sides. So you will get log
Sigma.
x with the base 2 equal log 2 in the power of y with the base 2. What the property of the logs? If we have power, what happens with this
It
power?
goes to the front.
It goes to the front, so equal y times log 2 with the base 2. What is log 2 with the base 2? 1. So we get y equal
Log 2x.
log x with the base 2. So they are inverse function f of x equal g negative 1 x and vice versa. So what we know about the graphs of the function and its inverse? They are first symmetrical,
Y equals X.
symmetrical in the line y equals x. And what was domain of original?
Is the range of the
Range of the inverse, and vice versa. What was y-intercept of the original becomes x-intercept of the inverse. So if this is the graph of an asymptote, asymptote swap with the y-asymptote, we have y equals 0, and that was 2 in the power of x. And intercept is 0, 1. So what will be the asymptote for log graph? This is a 2 in the power of x. Log inverse function. So what was y asymptote becomes now x asymptote. So we have asymptote x equals 0. What was y-intercept becomes x-intercept. So 1, 0. And reflecting it in the line, if you draw line y equals x, if you draw the line y equals x, we get the log graph. This is y equal log x with the base 2. Yes?
So if we're doing that in a test or something, would we be expected to do it in different colors?
No.
Okay.
You don't have to.
So if you have to draw a graph, and then you transform the graph, translate the graph so it has a different asymptote, how do we draw both asymptotes without, like if they're two x asymptotes, if that makes sense?
I understand the question. So you have basic graph with its asymptote and then you change it. My advice, if you have provided Cartesian plane, like coordinate grid, you draw there only final. And all your preliminary, you draw some x's on the side and do it there and draw on what's provided on the final.
Okay.
Now, let's sketch. Let's sketch graph of the logs with the sum transformations. So let's sketch the graph of the y equal 2 minus log with the base 2 of let's say 4 minus 2x. Of 4 minus 2x. But before doing that, if we have exponential function 2 in the power of x, what is domain?
0.
Domain of 2 in the power of x. All real numbers. Range was from 0 to infinity.
Real positive.
With a log. Domain of the inverse function is range of the original. So we have domain of the log from 0 to infinity. And what is the range of the log? All real. Anything means all real numbers. Okay, let's sketch this graph. What should be the first step before sketching the graph? Yes?
You can find the range of the range really easily.
First step.
It's
We need to make coefficient of x positive 1. So need to rewrite it 2 minus log 2 minus 2, and we have x minus 2. You must, before sketching the graph, please do this so you will see proper. In this form, it's very easy to make mistake to identify wrong transformation. When you make coefficient of x positive 1, it makes it much easier to find proper transformation. So what transformations we have here? Let's say, what is this?
In x-axis.
This
Reflection in y.
y-axis. What is this? Translation to the right. To the right. This is translation and these two dilation by factor no 1/2. dilation by factor 1/2 from y-axis. So,
That makes sense.
now,
No,
as graph, first, let's do it step by step. We start from this was the asymptote log 2x, and that was the graph with the y-intercept. We have reflection in, let's start from the reflection. Reflection in x-axis and in y-axis. This will be, when we reflect in x-axis, that will be graph. And then we reflect in y-axis, that will become the graph. So we have not finished it yet. This is just two reflection. This original graph of the log, so this is log, this is negative log. And this is, when you reflect in y, it's negative log negative x.
Yeah.
Make sense?
Yeah.
So we've accounted for this minus and this minus. What should we account it next for?
dilation.
Dilation
By 1/2.
by 1/2. So what it will change?
We get y.
It will change x-intercept. What will be x-intercept now? 1/2.
Why?
Negative.
What?
We have not done, always do translations last, please. Do translations last. So after dilation, we have this graph. This is negative 1/2 0. So we accounted for two reflection and dilations. Any questions? Make sense so far? Yes.
Where is there an x? Shouldn't there be an x asymptote at 2? Because it
We have not, first we have not accounted for translations yet.
Okay, alright.
We only accounted for two reflections and dilation. Now, translation 2 to the right, what will happen with the asymptote? Now asymptote will become x equals 2. X equals 2. And what 2 does at the front?
Goes up.
Move 2 up. But we don't really see it well. The only thing, it will change the intercept. And because we moved it 2 to the right, we will have now both x and y intercepts. Let's find them. Let's find them. So let's start from y-intercept. Y-intercept, we take x equals 0. We get y equal 2 minus log 2. And we have of 4. Log 2 of 4. What is log 2 of 4? 2. So what that equal?
0.
Oh, what mistake I've made?
Every single one. 2 to the power.
It can't be
Which
0.
mistake I've done with the graph?
It should go to the origin.
You should first
What the hell you say?
calculate this before sketching the graph.
Oh,
Then
damn.
you will know.
Oh, so you know the x and
So
y.
don't sketch the graph before finding intercept.
Tricked us, Mr. V.
So this graph, and because it's 0, it will be x-intercept, both x and y-intercept. So that will be the final graph. That will be the final graph. That is final graph. With the intercept both x and y 0, 0. Make sense?
Yes.
Yeah, that makes sense, Mr. V.
Okay, and one more last thing for today. is last thing for today is
Reggie is a pushy button. Pushy button.
is using logarithms to solve exponential equations and inequalities. So let's say you need to solve. Okay, I can see someone want to come to the board and show to the class how to solve the next equation. -2 times 10 in the power of x plus 4 equal 0. How will we solve this equation? How will we solve this equation? Yes?
Make all the bases 2. No?
First I will rewrite it as 2 times 10 in the power of x equals 4. Not negative 4, positive 4. Divide both sides by 2, you get 10 in the power of x equals 2. Next step,
Log.
Log 10.
we take both log with the base 10 of both sides. That will make this x equal log 2 with the base 10. Log 2 with the base 10. Use a calculator. That will be exact answer required. You cannot do more than that. Or use a calculator. Can you please tell me what it's equal approximately? It will be something, I believe.
Yes.
1/2 will be about 1/4, 0.25.
0.3 or 1.
0.3, approximately 0.3. That is approximately 0.3. Okay, that's all for today. Like, subscribe, and donate to help fight terrorist countries and organizations, Russia, Iran, etc. Support Ukraine and Israel.